Alright, if you are watching this video, then I am not in class and I do apologize for that. I will be back as soon as possible. Um, and so we're going to focus on trapezoids today. If you didn't know, there are different kinds of trapezoids that we're going to explore today. And trapezoids are not part of the parallelogram family. So they have some different characteristics that make them not fall into that family. So a few vocabulary words about trapezoids that you're going to be hearing and referring to. Um, all of the angles are kind of called base angles because they're all next to a base. So the top and bottom are both called bases. Well, I shouldn't say top and bottom. It would be more accurate to say the two parallel lines are bases. So we have, that's what that little arrow means, remember? So those are the bases. A trapezoid only has one set of parallel lines, which is why it does not fall into the definition of a parallelogram because there's only one set rather than two sets. And then the other two are called legs, kind of like a triangle. So we have two bases and two legs, and then the angles are called the base angles. So these are the base angles for this one, and then these are the base angles for this one. You wouldn't say that this one and this one are base angles. So it's the two angles that go with the same base, if that makes sense. So if you get out this information, we're going to run through this kind of together. So a basic trapezoid, or all the trapezoids in general, is going to be this first line. So in general, we can't say that all trapezoids have all 90-degree angles. Opposite angles being congruent. I'm just going to draw a trapezoid here for you so you can look at it. So this would be an opposite angle, and those are not congruent. The number of opposite sides parallel is only 1, and the number of opposite sides congruent is none. Then consecutive angles, supplementary. Some of them. So I'm going to write same side interior angles. So if these are my parallel lines, remember, like parallel lines with a transversal. So this one and this one are supplementary to each other. And then this one and this one are supplementary to each other. So these are consecutive, but remember in a parallelogram, those were also supplementary, and those, and those. And so that's not true anymore. So the base angles are not supplementary, but same side interior angles are. Okay, so I hope that makes sense. Diagonals are congruent? No. I'll draw another trapezoid for you. This diagonal and this diagonal are not necessarily congruent. They don't bisect each other, they're not perpendicular, and they don't bisect opposite angles. They are lame. All right, an isosceles trapezoid. Let me erase all of this. Whoa. Oh, that was interesting. An isosceles trapezoid, like an isosceles triangle, that has those two legs congruent, and isosceles trapezoid has those two legs congruent. So it still does not have all 90-degree angles. Still no there. Still one there. But then we have one pair of opposite sides congruent, and that would be these two. So that's a pair of opposite sides congruent. This is still true. So these two angles are congruent. I'm sorry, are supplementary, and these two angles are supplementary. So that's still true. In this case, the diagonals are congruent. This diagonal and this diagonal. And it's because you have these legs that are the same, then when you make the diagonals, they are also the same. but they don't bisect each other, they're not perpendicular, and they don't bisect opposite angles. The last kind, special kind, is a right trapezoid. So just like a right triangle has a right angle there, a right trapezoid has a right angle. So for a right trapezoid, there are two right angles, because if these are parallel and this makes a right angle, then this would have to make a right angle as well. Opposite angles congruent is none. Opposite sides parallel is one. Opposite sides congruent is none. Same side interior are still supplementary. Diagonals are not congruent. They don't bisect each other, not perpendicular, and not bisecting opposite. So don't forget that these two are types of trapezoids. They just have a couple little special rules. But they're still parts of trapezoids, and really the main thing that makes things a trapezoid is this part right here. The fact that they only have one set of parallel lines. That's the big thing that kind of distinguishes them from a parallelogram. So if you could get some scratch paper, or if you want to work on a whiteboard to kind of get a few questions done, if I had been here, we would have done this whole class. But we've got to kind of change some stuff up. So I do want to run through some examples with you though, before you move on to work on your own. So we have some things to go through together still, and then you'll be able to work on your assignment. All right, so go ahead and draw this out and label all your things. And then in order to solve for these things, remember that these are supplementary and these are supplementary. So you just have to subtract those values from 180, which leaves you with angle A as 138 and angle C as 70. Your next example, because these are equal, that means my base angles are going to be equal. And then again, these are supplementary and these are supplementary. So subtracting 42 from 180, and A and B equal 138 and C equals 42. I don't know why it keeps doing that. Your next example, we're going to look at a right trapezoid. So if angle B is 90, then angle A would be 90. And then for angle D, you could look at the same side interior angles as being supplementary and find that that is 138. And then the height, remember the height has to be perpendicular to a base. So the height is 15. Next, we're going to step it up with a little bit of extra math. So a couple examples ago, we did the isosceles trapezoid, and these have to be equal to each other. So we can just set them equal to each other. And then you have some choices to solve. You could either put this in your calculator, y1 and y2, or you can just go ahead and solve it by hand, which I'm going to do. So I subtract x, I get 2x. I add the 5 and I get 12. So x is 6. And then when you just plug everything back in, 3 times 6 minus 5, and then x plus 7. In both of those cases, you get 13. So angle D is 13. To find angle A, it's your 180 degrees, inside interior angles being supplementary. So that would be 167. And then AD and BC are the same. So to find BC, do 8 times 6, 48. All right, this next one, an isosceles trapezoid. Remember, our diagonals are congruent. So we have AE is 2x, EC is 3x, and then DB equals 30. So if they're congruent to each other, then this piece, this piece, this piece, this piece, plus piece has to equal the whole, kind of like that segment addition stuff from a long, long time. So 2x is 5x equals 30. Divide both sides, 7x equals 6 again. Oh, okay, good there. Your next example, we have a right trapezoid. We're looking for AB, and we're looking for the measure of angle B. Well, I already know that that's going to be 90. And then I need to find that height right there. So if I block this off like that, because this part is 22, then this part has to be 22. And then this little piece left over is 8. I know that because this part, 22 plus 8, that's the whole thing that has to equal 30. So when I block this off, if you notice, I now have a right triangle, 10 and 8. And if I solve for that, then this is the same as this, and that's what I'm looking for. So those right triangles have not quite gone away yet. So we can do a squared plus b squared equals c squared, or 10 squared minus 8 squared equals b squared. So this would be the a, b, and c. So 8 squared plus b squared equals 10 squared. I didn't want to skip ahead and confuse anybody. So then you end up with this. 100 minus 64 is 36 equals b squared, square root. So b equals 6. What a 6 is interesting. Let's see. On this problem, I'm running out of time and there's still something I need to show you. On this problem, we're going to skip it. I'll come back. So one last thing about trapezoids, there's a mid-segment of a trapezoid. We've talked about this a little bit with some other things about mid-segments. It's like, it's just in the middle. So you have the two bases and it's in the middle of the two bases. And it divides the two sides in half. So because of that, then it's kind of like the average of these two. So you're going to take the top base and the bottom base, add them together, and divide by 2, and that equals what's in the middle. Okay, so for example, 2.5 plus 8.5, and then you divide that by 2, and you get 5.5. In this case, it's a little bit different. You want x plus 17 divided by 2 has to equal 13. So then to solve for x, you'd multiply both sides by 2. So x plus 17 has to equal 26. Subtract 17, and x equals 9. So basically it's like the average. So the top and the bottom added together divided by 2 has to equal this. Or if you want to think about it as the top and the bottom, or the middle part has to be, if you double the middle part, it would equal the top and the bottom. Okay. So that's it for your video. Go ahead and do your best on the other page. And like I said, I'll be back to see you as soon as I can.